Photosynthesis and color. The effects on photosynthesis by using different colored lights on plants. 3 plants are being tested in this experiment. The first is spinach, or Spinacia oleracea. Spinach was originated in Persia, which is now modern-day Iran. Spinach is a popular crop with $281.8 million in value in 2016 and covering 56,200 acres across California, Arizona, New Jersey, and Texas. Part of its popularity is due to it being a quick maturing plant. The next plant being tested is radishes, or Raphanus sativus. Radishes originated in southern China and remain a staple food throughout Asia. There are hundreds of varieties, but the most popular is the cherry bell. Radishes also mature quickly in about a month's time. The final plant being tested is lettuce, or Lactuca sativa. Lettuce originated in the Mediterranean and was first cultivated in ancient Egypt. Lettuce accounted for 1/5 of farmers' vegetable sales in 2022, coming out to about 1.5 billion in sales. The purpose for this experiment is to understand the effects that red, blue, green, violet, and orange light will have on the 3 plants being tested. This is important because we have a growing human population and it is critical to develop and understand the most effective ways to grow food for people, especially with climate change working against us. The hypothesis I formulated is based off of the understanding that sunlight is composed of a spectrum of colors, and when we observe an object, it is reflecting back the color that we are seeing and absorbing the other colors that we are not. With this concept in mind, I expect green to be the least effective of the colored lights, as it will have the least absorption due to the pigmented color of chloroplast being green. On the other hand, because the sky is colored blue, if a blue light is used, then I expect the plants to grow the largest due to a higher rate of light absorption into the thylakoids during photosynthesis. After the blue light, I believe that the violet light will be the second most effective, as it has short, strong wavelengths like blue light, then orange light in the middle, then red light as it has the weakest wavelength, and green light in last place as it will be the one reflected back. This experiment was conducted on a plant growth simulator. Each plant started as a seed in a pot placed indoors, approximately 25 centimeters from the light source. 3 of each plant then went through a 30-day cycle under a red, blue, green, violet, and orange light. At the end of those 30 days, the average of the 3 plants under each colored light was recorded. These are those results. This is a table graph of the spinach. This is a bar graph of the spinach. This is a table graph of the results of the radish, along with the experiment. And this is a bar graph of the results of the radish. This is a table graph of the results of the lettuce, along with a photo of the experiment. And this is a bar graph of the results of the lettuce. The results of this experiment on spinach, radish, and lettuce all indicated that blue light was the most effective light on the rate of photosynthesis. I was surprised by red light having the second highest growth in the plants, as I believed that the light waves would not have been strong enough. My hypothesis was correct in that the green light was the least effective light for photosynthesis absorption. If I conducted a similar experiment again, I would like to place the plants outside with colored bulbs around to see if a combination of the sunlight with the bulbs would give different results. These are citations of the references I used. Thank you.